Okay, so this is how you do problem number 17 on the Chapter 8 homework on page 256. So the book talks about this ice cream sign that is being suspended by a cable from with a 30 degree angle with a vertical, but it doesn't really give us a complete diagram, so I drew my own. So a 6M rod, obviously with a half of 3 meters, and I just omitted the ice cream sign over here, and as well as the tension and the force from the hinge. So one thing you always have to remember is that when gravitational force is pulling something down, it always pulls it at the center. So from 6M, its center would be 3M from the sides. So since the rod has a mg of 100 newtons, that means that at 3M, the force would be 100 newtons downwards. And the sign, it's a little bit tricky in terms of the sign because the sign is 4 meters wide, and the whole board is 6 meters wide. So half of 4 meters would be 2 meters from the end of the board. So 6 minus 2, that's 4. So that's how I got this 4. And it already gives us the ice cream board's mg, which is 500 newtons. And in terms of T, I just made it in terms of the angle made between this and the rod, and F has always the same angle as T when drawing the diagram. So I used equilibrium to find all the three formulas that we need. So the first thing I did was sum up the forces in the x direction, and we all know that cosine is the part of the triangle that is always in the x direction. So t cos 60 minus f cos 60 equals 0, which means that they're both equal to each other. And in the y direction, t sine 60 plus f sine 60 minus 100 from here plus 500 from here equals 0. So that means t sine 60 plus f sine 60 equals 600 newtons. And then the torque. So all we need to do is find the one that's going counterclockwise, or the positive. So t, and then the distance from the axis of rotation is 6 meters because they're both on opposite ends of the cable. So that would be 6m, and then sine 60 because the angle made between this thing and the tension is 60 degrees. So sine 60 minus, and this is going clockwise, so it's negative 100 newtons, so 100 newtons, and then makes a 90-degree angle. So, and sine of 90 is always 1, so I just omitted sine 90. And 3 meters from the axis of rotation plus 500 newtons. This is the sine, plus 4 meters from the axis of rotation equals 0. So you do the math, t sine 60, and you eventually get this. You can solve for t and you get 443 newtons. And from our initial two equations, we substitute t, and you can get the horizontal component of the hinge force, which is 221 newtons, and then you can do the same for the vertical component, which is 217 newtons. And that's how you do the problem.